We're going to go ahead and try another question now using separable differential equations. Same book as we've been using for the past few videos, the elementary differential equations and boundary value problems by Boyce and Depriva. And basically we're asked to solve the initial value problem, and then they give us a problem, and then they're also asking us to find when it attains a maximum value. So we'll go ahead and take a look at that too. So the initial value problem is y prime. Remember, y prime is the same as dy dx. So if you're more familiar with that, you can convert that to a dy dx. On the right hand side, we have 2 times 1 plus x times 1 plus y squared, which might look daunting at first, but it won't be as bad when we actually get into the problem. And then the conditions that were given are y of 0 is 0. So that's basically just the point 0, 0, right? X is 0, y is 0. And then they're asking us for the maximum value as well. So let's get into this. We will convert that to a dy dx because that's maybe a bit easier on the eyes, at least for me. Over here we have 2 times 1 plus x, so we're not going to change anything here, and then a 1 plus y squared. How do we make this more into that classic separable differential equation form? We divide both sides by 1 plus y squared, and we put the dx on the other side by multiplying both sides by dx. So over here we'll have dy divided by 1 plus y squared. That's the left hand side. On the right hand side we have 2 times 1 plus x, so we can just go ahead and distribute that out. So that's 2 plus 2x. Put the brackets, don't forget that. Then we have a dx over here. What's the next step? I didn't mention this yet, but make sure to pause the video, give this a go yourself, see if you can get the right answer. And remember, the other part of the question is to find the maximum value of y. Find maximum value of y. So I didn't write it yet, but just go ahead and do that as well. Anyway, continuing, we'll get the integral, right? So we integrate both sides, dy over 1 plus y squared. Over here we have the integral of 2 plus 2x dx. Left hand side, you should probably be able to recognize this. This is arctan, so inverse tan of y. Over here we have the integral of 2x is x squared. The integral of 2 is 2x. Sorry, so it's x squared plus 2x. And then there's going to be a constant as well, so that's going to be plus c. Before we write this explicitly in terms of y, we can just find c right away by plugging in 0, 0. When you put in 0, 0 here, you get c on the right hand side. On the left hand side, you get arctan of 0, which is 0 as well, which means that you have 0 equals c, so c equals 0, and we can just remove that. Now we want to get it into an explicit function of y, right? And when you do that, how do we find that? Well, how do you reverse and inverse tan? You just take the tan. You take the tangent of both sides. You get y on the left hand side is equal to tan of x squared plus 2x. So that's going to be y, right? That's our explicit, that's our initial condition. We're using this initial condition there. If we want to maximize y, we want y prime to equal 0. When is y prime equal to 0? Well, this is never going to, the denominator is never going to make it 0. The numerator can make it 0, and that's when x is 1. X is negative 1. Sorry, my bad. They were asking for the minimum value all this time, which makes sense because this is a negative number. You probably assume that it goes higher than this at some points as well. This is a minimum value, not the maximum value, and that's exactly what they were asking for. The other questions were mostly maximums, so I think I read those and said maximum instead. This is a minimum value, not the maximum. This is a minimum. And that's it for this question. So hopefully you tried it yourself. Sorry about the mistake between the maximum and the minimum. Should have been a minimum all along. And I'll see you in the next video. Thank you.